So welcome to the, so you know the name of the talk is called Easy Path to Machine Learning, right? There's no such thing. But at least there can be an easier path to machine learning, all right? And so I'm going to show you how to do that. In particular, how to use Google Cloud Developer Tools to help you in that journey. I'm Wesley Chun, and I'm a developer advocate at Google. If you've never heard of that title before and you want to know what that means, it just means I'm a software engineer with social skills. That's all. I mean, you could put me in a dark room with a pizza, Diet Coke, and a computer and keyboard. You can do that, but you can also put me on stage, all right? So anyway, so that's me, that's the job, that's the talk, and if you have any questions like way after we're all gone and gone home, there's a link to an open Google Doc here, either barcode or short link, and then you can just plug in your questions there, okay? All right, so a little bit about me. I am not a data scientist. All right, so what you're hearing is actually a journey from someone who is a developer like yourself, who doesn't necessarily have that scientific mathematics statistical background, right? Yes, I did take a stats class in college, and yes, I took a bunch of math classes, right? But I'm not a data scientist, but I'm very interested in machine learning because it seems to be the hot thing, and maybe it's a good thing I should put on my resume. And of course, at work, everybody else was doing machine learning. I didn't want to get left behind, so I wanted to learn myself. So you're getting a picture of my own journey. So what is my job at work? My day job is to ensure that developers like yourselves and also future developers, so actually I focus on higher education, so teaching university faculty about Google Cloud and how they could use it in their classroom for their students and stuff. So that's really my day job. Speaking to industry engineers like yourselves is what I've been doing before I started higher ed, so it's just a slightly different audience. So my job is to make sure developers are successful using Google Cloud and other Google developer tools and APIs. Before I came back to the cloud platform team, I spent the last 5-6 years on the G Suite team. And so I was the host for the G Suite Dev Show. So if you see my videos online, they're mostly about G Suite technologies, like how to code Google Drive, Gmail, Calendar, DocSheet, Slides. I haven't made enough. I've made some cloud platform videos, but not that many. And moving forward, I'll probably be making hybrid videos that actually use both parts of cloud together. So that's something that I'm going to work towards. However, my background is, like I said, I've been a software developer several decades. The most well-known thing I've done, that you probably have heard of, I was one of the original 10 engineers that built Yahoo Mail about 20 years ago. I also written some Python books. But I'm also a teacher as well. I've been teaching for several decades, actually longer than I've been an engineer, interestingly enough. It's just been a parallel career. It's the only way I can afford my mortgage is to have 2 jobs, you know. It's kind of crazy. Anyway, and then my academic background. Okay, so what are we doing here? So big data is everywhere. We can't escape this. I mean, I guess it started with the first tweet or maybe first Facebook post, right? But you just can't escape that there's a large amount of data everywhere. And this is the reason why NoSQL was invented. It used to be the case that everything fit inside a relational database, right? But that's not the case anymore. So now we have NoSQL. And then on top of that, not only do we need a place to store our data, we need to be able to analyze this data, right? And while artificial intelligence and machine learning have been around for decades, like it's been around for a long, long time, we've never really needed to use it. And we've never really had the compute power available for all of us to be able to use it in a sort of a cost-effective way. But that's different now with cloud and with the cost of memory dropping, the cost of disk dropping. All of these things are actually making machine learning come to the forefront. Okay, but it's been around for a long time. And so why do we need it? Well, we need AI and ML to help us analyze this massive amount of data. All right. Like I said before, it does require a certain level of sophistication with mathematics and statistics, and not all of us have that. Okay, and so we really want to bring the power of machine learning to everybody, regardless of what your background is. But in order to get started, you gotta, it's better to take sort of like small steps than it is to try and take a giant leap, right? And so I'm trying to show you what some of those smaller steps are. Once you have everything ingrained in your head, you know the vocabulary, you know the speak, the text speak, then you can go ahead and go to some of the more advanced tools. Okay, so it does have a little bit of a steep learning curve, so I'll tell you that up front. It's not without studying and practice and things like that. Just keep on taking online courses, tutorials, do as much stuff as you can. so that you're familiar with everything. Try different APIs. Don't just stick with Google's APIs. Try Amazon's AI APIs. Try IBM Watson APIs, just to get a breadth of a flavor of what ML and AI are all about. Okay? And so the good thing is that a lot of these companies, cloud vendors, have APIs that are powered by ML to kind of like ease the transition to having you build and train and deploy your own models. Okay? And so the basic tagline, I should put this on a bumper sticker, is if you can call APIs, you can use machine learning, and that's it, right? That's all the skills you need. Okay, if you can't call an API yet, got to work on that part first, all right? But hopefully with a lot of well-known libraries that are available in JavaScript, Python, and lots of languages, that you'll be able to kind of like make that leap in a much quicker way and get there sooner than it is to start from scratch with machine learning and being able to build, train, and deploy your own models. All right, so how's this talk going to progress? I'll give you a high-level overview of what machine learning is. Then we're going to talk about Google Cloud. And then specifically the APIs, Google APIs more in general, not just cloud APIs. And then I will focus on cloud machine learning APIs. And then on top of that, some other Google APIs that you may want to consider because they may help. And then provide a couple of inspirational apps that use lots of different bits of cloud that include machine learning APIs. And then we'll wrap up from there. So I'm going to try and cram all this in 60 minutes. Not sure I can do that. I will try really hard to do so. In fact, before I do this, I want to see if I installed something already. I don't know if I have it ready yet, but I'm going to give it a shot. No guarantees that it's going to be here. Okay, no. All right, so you're going to wonder about a little link I have later. All right, I'll talk about it. I'll talk about it later, so don't worry about it now. No fretting. Okay. That was one thing that I didn't get a chance to do today before I left the house. So let's bring back the slide presentation. And then make it full screen again. Okay. All right, so what is machine learning? So AI and ML and making computers smarter to help us understand more and get more data, insights on data than we had before. Okay, so AI in general is sort of like a large, encompassing term that means anytime we're building some sort of intelligence that is in code, that is not done by a human. That's sort of like generically what AI is. And then machine learning is more specific. It's basically how to write code that are smarter. And things can be hand programmed. It doesn't have to be, always building and deploying models. It could be models that you built by hand. Okay? So machine learning is being able to kind of make code learn from experience instead of just hard-coded, rules. Okay? And then deep learning is one level deeper than that. And that is making code even smarter, being able to learn even faster than the typical machine learning code. So this is sort of like what it looks like from the technological landscape and then also the terminology, so you can understand where everything fits. All right, so let's go back and ask a more simple question. How many of you people out there know how to recognize the difference between a puppy and a muffin? Okay, how are your brains doing that? Visual, meaning what? What kind of visual things? Shape, like rules, basically. You're defining rules like the shape. Like maybe it has eyes or a nose or whatever, right? And then a muffin could be something that looks like a mountain surrounded by a paper wrapper, right? Something like that? Okay. Let me ask you the same question again. How many of you can tell the difference between a puppy and a muffin? So you know that was a bait and switch, right? For this picture, that was just to lure you into a sense of security, a false sense of security, right? This is what it really looks like out there in the weeds. Okay. I think my rule for eyes and the nose probably doesn't work out, because who knew that there were such things called blueberries? Right? Shape, I don't know. I can't really, they're sort of roundish. I don't know. Right? Not so good. Okay, so can you imagine writing a piece of code that can recognize the difference between a puppy and a muffin? Okay, it's already sort of tricky for a human to do it here. If it's tricky for a human, it's really hard for a computer. All right, it already takes a certain amount of work to be able to write code that can do this. But then ensuring that same machine learning code you have that can do this that can also do that, that's much harder. Because these things are really, right, it's tricky. Okay, so what is machine learning then? We can't just use rules. Rules by themselves is not good enough. So you actually need rules and experience. Somebody has to tell the computer, this one's really a dog, this one's really something I can eat. Well, I mean, I guess theoretically you could eat dogs too, but depending on your culture, right? Okay, so I'm not gonna make an HR violation right now. Okay, so you have to use some sort of experience. Okay, so rules are great, right? Starting with eyes and a nose, that's a good start. Maybe ears, right? Muffins really don't have ears generally, but eyes and nose a little harder. So anyway, so experience. So here's kind of like how things work. So when you're training, doing machine learning training, the software that learns is called a neural network, and the reason why it's called that is because you're trying to sort of like simulate how a brain works. A brain works by seeing patterns and seeing shapes, like the gentleman mentioned earlier, right? Over time, throughout your lifetime, you've seen lots of examples of dogs and cats and muffins, so that as an adult you can tell the difference. Maybe a little baby can't quite yet, but I think babies are pretty good at telling differences between things. Okay, so what you're doing is you're sending little signals to yourself in your brain, and slowly but surely, it's almost like doing like a select on a database. At some point, it's going to select the right things. You follow the paths that tell you what the actual outcome is, and you know for sure it's a dog, a cat, or a muffin. Okay, so that's step one, is to make the training happen so that your brain recognizes these things. Then what happens is, after you pass in enough data of cats, dogs, and muffins, then you can start asking the question like, well, looking at this, I'm going to use those same things that activated my neurons earlier to help tell me whether it's a cat, a dog, or a muffin, right? And slowly you filter all the stuff that can't possibly be, and you keep on going up until you have sort of like the final answer, all right? So this is the testing phase. How good are my rules and my experience helping me with trying to figure out what this thing actually is, right? So anyway, that's how a neural network works, all right? Does this kind of help explain sort of like what this, because there's a lot of buzzwords, in any technology. If I'm talking about networking, I'm talking about TCP, I'm talking about sockets, IP addresses, every type of technology has its class of vocabulary words. So neural networks is one, okay, in AI. Okay, good. So there is a lot of machine learning used at Google. We're throwing it into lots of different products to try and make the user experience better. So for example, if you have something like a Google Assistant, you can actually ask it a question, and it goes and fetches it based on the patterns of the speech that you've used. Then it figures out what are the nouns, what are the verbs, and what are the objects, things that you're looking for, so it can go and find out answers that hopefully are close to the things that you're seeking. Okay? And then similarly, Google Translate now has been endowed with a lot of AI and ML, which makes it much more easy to use. In fact, I don't know if you guys have discovered the camera mode yet, so this is fairly new. I think it's only been around for a couple of years, but it used to be just plain text driven, right? But now you can actually use the camera mode and take pictures of signs, and it should be able to do sort of like a live translation. Very useful when you're in a foreign country and you're sitting in front of a menu, okay? Or they don't have an English one. Okay, I've actually used this. The translation is not perfect every time. I've seen things on menus like, no, I think I'm going to skip that. But other times it's like, oh, it says beef, it says, braised or broiled or whatever, and that kind of like leads me to, maybe I'll try this, okay? And then finally, if any of you have the Google Photos app, did you notice that it has a search bar? Right, it's supposed to manage your photos, you're supposed to sift through them in a chronological order and stuff. But being able to search through your photos is amazing, right? Like I'm going to look for only the pictures that I took when I was in Costa Rica, right? It can actually recognize the background and the sort of like the the nature and all these kind of things. It's able to pick out most of my Costa Rica pictures. And the other thing is, if it kind of also leverages sort of like the date and timestamp, it kind of knows I was sort of in Costa Rica at this time, so it can sort of like gather pictures that are slightly weaker, but it's pretty strong if it falls within the same timestamps, right? So if you use lots of different signals, you can get sort of a more accurate answer. Okay, so lots of Google products have this. If this was a longer talk, I would have more examples of this, but this is good enough. Okay, all right. So how do you get started? first of all, what do people think machine learning is? They think it's, oh, you have lots of data, and then you have to do all this crazy hard math, and then you have these magical results. Okay? In reality, that's actually close to accurate. Okay? But there's a few steps in between. First, you have to collect lots of data. Then you have to organize it and clean it up. That probably takes more than 50% of the time, right? If your data is bad going in, then your models are going to be bad anyway, right? You have to make sure that the data is accurate and that it is labeled correctly so that your models can be accurate. Bad data, bad input is bad output, right? You got to start by making sure everything is great. And then what you can do is you can train your model based on your cleaned up data. Then you use machines to sort of like, kind of formulate what this model is. And now you can go and deploy this model to make predictions on new data that you have. Okay, so this is much more like what real life is like, okay? But it's not that different from the first slide, okay? It's just that you have to take the sort of like the magic out and make it realistic for developers to understand and be able to start using right away. Is there a question? So the creating model, which basically means you're training the model. You're starting with one picture that's labeled correctly. You build a model from that. Then you further train it. So this should say training, creating the model and then comma training. So the more data you have, the better this model can be. And then so this part actually does the computational work, all right? And then you have a deployed model. Okay, so you can kind of like slightly merge these things together. You can slightly merge these things together. This is kind of in the middle, okay? All right, so moving on. So this is the way, as developers, we've been taught. You basically have a bunch of rules, which is your code, F. Then you have your data, which is X, all right? Then you pass it through. You call F of X, and those are your answers, right? With machine learning, you have like a little bit more behind this. The rules are changed just slightly. What happens is you have to have existing answers, which is your data set. So the data is here, and then the yes or no. This is a dog, this is a cat, this is a muffin. So those are the answers. You build the model, and then out come the rules plus experience. Okay, so it's slightly backwards. You have to have some answers to start with. Okay? All right. So for example, one thing that's interesting that you can do is you can detect things like articles of clothing. All right, so you can tell, your eyes already know what is a shirt, what are a pair of pants, what are shorts, what is a skirt, what are shoes, right? But now you have to try and train a computer how to do this. So in the end, this is what I want you to do. The goal that we're shooting for is for you to eventually be able to get to a place where you can actually write code to make this happen. All right, so to further flush out the diagram that we just had on the previous slide in order to do something like this, okay, so again, we start, oops, where'd it go? Let me see. Okay, yeah. So this is being able to recognize clothing, okay? And so the project, there's a data set that's pretty well known out there. It's called Fashion Amnesty, all right? And that has 70,000 grayscale images. There are 60,000 images for training, and then 10,000 for testing. And these fall into 10 categories like shirt, shoes, purse, skirt, pants, all right? So there's 10 different categories. And each of these are just small 28 by 28 pixels, all right? And so at the end of this talk, I want you to get familiar with AI first, use APIs, and then you can come back and build your own neural net using TensorFlow. So this is full on. This is the goal we want you guys to arrive at, is after you've gotten familiar with the APIs, you've gotten familiar with the terminology in machine learning, and you've used the APIs, now you've gotten up to speed, and now you want to build and train your own models from scratch. This is the first tutorial that you should try once you're there. So I'm showing you the end goal of where I want you to be. And then let's talk about the intermediate steps, okay? So this is available as one of the first TensorFlow tutorials using Keras. So TensorFlow 2.0 has incorporated Keras into it. If you're unfamiliar with this, Keras is a higher level library that makes using TensorFlow a lot easier, all right? So anyway, so if you see these, the icons, one is TensorFlow, the other is Keras, and this is the classification tutorial. Okay, so what happens is you have these images. You'll have something like this. Each image that's 28 by 28 pixels, I think. Yeah, exactly. So you'll have an image like this. You'll have lots of different ones, and this is what is the training data. And then you'll be able to make predictions on it. So, oh, actually, I'll show you a little bit of code, which is great. So again, this is where we're going to arrive at the end, but I'm going to show you the intermediates. All right, so you'll import the Keras module, and then you'll connect to the data set that you've downloaded, and then you have a bunch of, if you're a Python developer, then this is using the numerical Python library, so it creates different NumPy arrays that load the data. And then so the training data will have images, and then it'll have labels to help you identify them. Numbers are very easy as labels, because then the computer can kind of like go, oh, this is a 9, this is an 8, this is a 6, this is a 3. All right, and then test images and labels are the same thing. The cool thing about numbers is that you can assign different text to the numbers depending on what the language is, right? So as long as you have a number, you can enumerate and then have your code in any type of like human language, depending on who your end audience is that's going to use this. Okay. All right, and then let's see. So anyway, so going back to this original model, which is the training bits. Okay, then we have a final model where you can make predictions. So that is called the training phase, and then once you have a working model and you want to make predictions using new data, then you have the inference phase. Sorry, you can't see it from that. But anyway, so this is kind of how it works. You do the training, and then you make predictions. Okay, so that's what you're going to do at the end. And so when you do this tutorial, once you're ready for it, all right, these are the steps. You're going to import the data, then you're going to sort of like explore, pre-process it. Fortunately for you guys, it's already been cleaned up, all right? So you'll build your model by setting up the layers, compiling it, then you're going to train it with the training data, evaluate it with the test data, and then you can make predictions on new images. And of course, have fun, all right? So that's the interesting thing. Once you develop a model that can actually predict some of these things and try it with some new pictures that you upload, it's a pretty great feeling, because like you built a model that works accurately enough to actually help you with these kind of predictions. All right, so how do we get there? So let's talk about some APIs before we arrive at that. Okay, there's a lot more people in there now. All right, you guys learning something yet? All right, so look like you're learning something. Okay, good. I made you smile by making you laugh. So that worked perfectly, suckers. All right, so let's look at some Google Cloud stuff. What is Google Cloud? People get confused. People think Google Cloud and Google Cloud Platform are the same things. I say, no, look, the icons are different. They're not the same thing, okay? When you say Google Cloud, you're talking about an organization that happens to employ me, all right? We make two well-known product groups. One is the Cloud Platform, which we're going to mostly talk about today. Then the other one is G Suite. So if you know Gmail, Google Drive, Calendar, Docsheet, Slides, that's G Suite. What a lot of people don't know is that behind each of these apps that you know how to use, there's an API, so you can code them as well. There's nothing more satisfying than taking data, doing some big data analysis on it, doing some machine learning on it, and then exporting it into a spreadsheet, then telling the spreadsheet to build a chart, then creating a slide deck based on the data and the chart, and then showing that to your boss, right? You can do that all in code within one step. Don't be afraid that you can't cross over between them, right? Because otherwise, if you just use this over here, the best thing you can do is output it as CSV or stick it into a relational database, right? But a spreadsheet is much more visual. So really, I think it's kind of like it makes sense to use both sides of the cloud, all right? And like I said, there's APIs on both sides, so take advantage of that. Okay, so we're going to focus on Google's machine learning APIs. There's 6 here that are pictured. So you can gain insights from data using our pre-trained machine learning models. Okay, so the hard part is the training bits. To getting the data, to building the model, to training the model, you have to have a training set. All right, so what you're getting here as a bonus is if you can call an API, what you're doing is you're accessing Google Research's and Google Brain's pre-trained machine learning models. We've already done the hard work, the training for you. All you're doing is just using those models that we've already made. All right, so you're passing in the new data to our model, and our model is responding back with what it sees based on its training. Okay, so here are the anyway, so this is the same technology that's in all of our apps as well. It doesn't require any knowledge of machine learning, and like I said earlier, if you can call an API, you can use machine learning, which is awesome. Okay, so the 6 that are pictured here is the Vision API, the Video Intelligence API. There's a pair of speech APIs, speech to text as well as text to speech. There's a natural language API, and then there's the API for Google Translate. Okay, so those are the 6, and I'll show you some examples of some of these. Probably the one I'm going to use the most is Vision, just because we're short on time. Okay, but we'll see how far we get. Okay, so what we're doing is we're using pre-built models. So that's using the APIs. We have another product which I'll talk about, which will let you customize these APIs, all right? That's kind of like machine learning. You can further train our APIs if you didn't know that before. Otherwise, you are going to be doing your own models, all right? If you're going to be doing your own models, you're going to be using TensorFlow and Keras, or scikit-learn, or PyTorch, or any of those. But if that's the case, you have to get your own infrastructure. In other words, you have to get your own hardware, your own VMs, your own GPUs, and that's fine. You can do that. But if you need help doing that as well, we have a tool called Machine Learning Engine, or ML Engine, which actually will do all that for you. It is a managed platform that lets you build, train, and deploy models without you having to worry about infrastructure. But if you have to do everything yourself because you want the full control and you want to get your own VMs, you want to get GPUs, TPUs, then you're on the far right-hand side where you're directly using these open source SDKs, building and training your own models, and using your own infrastructure, whether it be in the cloud or on-prem or whatever. Okay? So that's sort of like from the beginning all the way to the most advanced. So we're going to spend most of our time here, and we'll talk about this as well, and then one slide on this. Okay? Okay, so REST APIs, what are they? How do you use them? So you have to use GCP. So all of these APIs are available in the cloud platform, and the way you get to the APIs is you log into your Google account and you go to the cloud console. Okay, this is the hub of all your activity, and there you're going to be creating projects. Every application you create requires a project, and every project has to have a billing account. Okay, so you have to actually back your billing account with some sort of solvent financial instrument. Okay, generally it's people's credit cards. All right, otherwise you might use the free trial if you haven't already. People who are new to cloud platform, you get $300 of free use for 12 months. Okay, otherwise if you're in higher education, we provide education grants so that professors can allow their students to use our cloud without them punching in their credit cards. All right. The good news is that most of Google Cloud's APIs has a pretty generous daily or monthly free tier, and you have to actually exceed that tier in order to incur any kind of billing. All right, so you may start using our APIs but not notice your credit card getting charged at all. Actually, Google's not really good at charging money for anything anyway, right? So it will be a little while. I mean, of course, if you're using GPUs and you're just training a model by yourself with a VM, yes, you're going to notice it's going to hit that $300 pretty quickly, right? But generally, most APIs have a pretty decent free tier. If you want to know what the free is exactly, cloud.google.com/free. All right, and that tells you about the free trial, the $300 free trial, but it also talks about the always free tier, which is the free daily and monthly quota that you have before you get any kind of billing. Okay, so in the Cloud Console, there's a list of one section. It should go all the way down to the floor here, but this is all the cloud platform products that you can access. So it starts with compute, then it goes to storage, then like networking, logging, security, data. It just keeps on going down all the way across. There's just so many. So that's one place you need to go. Another thing that you should look at is the billing. So that's where you plug in your credit card, create a billing account. If you are going to be developing a project or application with other team members, there's the Identity and Access Management, IAM, and admin. So you can add other users and give them certain permissions, whether they be a viewer, an editor, an owner. Okay. And then the last one, probably the most important one, is which APIs do you want to use? Right? So here you have to go and enable the GCP machine learning APIs that you want to use. So when you click on this, you go to what is called the API Manager. And that's what we have here on the next slide. So this is the API Manager, or in other words, we call this the Developer's Console. All right, if you're not a developer, all right, yes, you can still create VMs and stuff, right? But it doesn't mean you're a developer, right? So developers use APIs. So when you click on that, you can get to the API Manager. There's also another URL you could use that takes you straight there, so you don't have to go to the Cloud Console first before going into the admin thing. Okay, thank you, appreciate that. Okay. So here you have 3 tabs. One, you have the dashboard, which is what you see here. This is very useful for your apps because this has a bunch of panels that are very, very useful, such as how much traffic is your app getting, how many errors is your app generating, and what's the average response time to your users. And then down at the bottom is a panel that shows what are all the APIs that you've enabled. So you can see how much traffic they're getting. You know, how many API calls to the Vision API are you using and all these kind of things. So very useful application statistics. The second tab is the library tab. I don't have a picture of that here, but when you click on it, it's basically where you enable and disable any Google API you want to use. We only enable a few by default, and they're mostly GCP ones. But we certainly don't turn them all on because that will just require too many resources. So you need to just toggle on or off the ones you're going to use. There'll be enable and a disable button, okay? So that's the library. In fact, and there's also a search bar. So as soon as you pull up the library, there's a search bar looking at you. I don't know why, but some people think Google's a search company, you know. But anyway, so if you want to use the Vision API, you would just start typing VIS, and then it'll start bringing up anything that has the word, you know, Vision in it, okay? Then the last tab is the Credentials tab. So that is where you obtain application credentials. In order to call an API, you need to have one out of 3 different types of credentials. One is the API key. So those are simple APIs that you use just an API key. Generally, this is the sort of like the least secure, and you'll only use it for when you're accessing public data, like looking for a place in Google Maps, searching for YouTube videos, sending a sentence to the natural language API, and querying for public Google Plus posts, if you can do that anymore, but I don't think you can. So anyway, so all those are examples of public information, right? So those APIs only need an API key. Second type of authorization is, let's say you want to look at somebody's Google Drive files, or maybe you want to modify somebody's YouTube playlist. Okay, well that's user data, right? That user needs to give permission to your app to accessing their data, right? So in that case, we use OAuth, which is more secure because the user has to grant permission to your code to access their data. So that's called user authorization. When you go to the Credentials tab, that's listed under OAuth Client ID. The third type is the type that we're probably going to be using the most, and that is I have an app in the cloud and I'm trying to make a call to an API. I'm not a user, okay? The data belongs to an app, okay? So that's called service account OAuth credentials. So that's the third type, okay? So that's the main one that you're going to use. And in both cases for OAuth, as soon as those credentials are created, it's going to prompt you to download those credentials that it could be used to ask for an OAuth token from the Google API, okay? So again, with a user auth, the user will see that little permissions box. You know, it says this app needs your permission to, and you click accept. But for service accounts, since you are writing code on behalf of the application, then you get that full credential right away. So there is no prompting of a user because the application by default has already granted permissions, okay? So those are the 3 different types of credentials you can create on the Credentials tab. And by the way, anytime you see a blue box, it means I made a video behind it. So if you want to hear, you know, repeat this again because you fell asleep the last 3 minutes, you can check it out. Although in this one, I don't talk too much about service account credentials. Okay. Yeah, there should be a link to the slides at the end on the last slide, so you have to stay. If you leave, tough luck. Okay. See, captive audience. I love them. All right, great. So here's an example of a simple API. So I only need an API key. Again, you don't need OAuth because I'm searching for YouTube videos or places on Google Maps. But for OAuth, you're going to need some code in here that does either user authorization or service account authorization, like accessing GCP APIs or accessing somebody's Google Drive files or somebody's YouTube playlist. Those are all either data that belongs to a user or an application, therefore OAuth is required. Okay, so just so you know, when you look at all the code samples, you're going to see one type of or the other. Yes, simple and authorized. Okay, next. All right, so let's focus on cloud machine learning APIs. That's why you're here, right? Easier path to machine learning by just calling APIs. So we'll start with Cloud Vision. So lots of examples with Cloud Vision. It lets developers understand the contents of an image and it extracts various types of metadata, okay? By the way, what's really cool is every single API, and we'll do this if we have time at the end, the home page of all the APIs will have a demo, okay? So if you go to this home page and you have a photo on your computer, you can actually upload the photo right in the browser, and it will actually show you what the Vision API's pre-trained model detects in your image. It'll show you what the request payload is that your app would send. It's just a JSON payload. It'll show you what the structure of that looks like so you understand how to send a call to the API. And then it'll show you the response JSON payload, which is what you get from the API. So you can kind of like, you know, in your mind reverse engineer how it works so that you can use it immediately, okay? So that's that. All right, so here's some simple Python code that will take the endpoint you created to the API. So there's some setup code that we're not showing here. Once you have an endpoint to Vision API and you give it some metadata like this is where my image is, and you say, hey, annotate this image. In other words, go tell me what you see in this image and give me the responses. I can say, hey, what are the objects that are detected, and give me a confidence score as to what you think you see in this image. And then another feature that the Vision API has is that if it detects humans in it, it can also give you some facial feature annotations, like is this person happy or sad or whatever. So we're going to do this, show you what this looks like for this particular image here. This image here. The output is, these are the objects that it sees in the image, and this is the confidence score of how likely that those images are actually in the photo. And then here's a demo of the facial features. Okay? So that's that code, and this is not a lot of Python code. Of course, you can do this in any language you want. It works in a very similar way. You take it apart. You send the results in the same way. You get the responses in a similar way. You just loop through all the results, and then you just display them. This is just a print statement. I'm just displaying things, right? But you can throw things into a database, a spreadsheet, or whatever processing you want to do after that. Okay? So this code may look a little long. Okay? I didn't even show you all of the code. But I do want to tell you a little bit of good news, and that is I just showed you sort of like the harder way of using GCP APIs. The good news is that it's even easier if you use the GCP SDK and higher level client libraries. So Google Cloud GCP APIs generally have their own high level client library, so you don't have to go through all this low level code and see all that Python code that I showed you. The reason why I showed you the low-level way is because some of our other APIs that are older, like the YouTube API, the G Suite APIs, those all use that same lower-level mechanism. And so if you plan on using other Google APIs, it's probably better to write the low-level way. That way you can access all Google APIs versus if you're only writing code that uses GCP, then you might as well use the higher-level libraries and not deal with the extra code. Okay? So the next few examples that I'm going to show you are other examples of using the Vision API, but using the higher level libraries, and you'll see a significant reduction in the amount of code. And in fact, I only showed you one page. I didn't even show you the setup page, which is the metadata that I gave it, creating the endpoint to the API. I didn't show you any of that. This demo is actually 2 screens of Python code, and that's a lot for a Python developer. I can't handle more than 1 screen of code, right? So let's move on to the next example, which is detecting doing the object detection like we did with the fellow on the previous slide. But look, this is the entire app. If you're using a higher level Vision API client library, you just have one import. Okay, here's where my image is. It could be any kind of URI, like it could be HTTP if it's online. But if I have this picture of a Shanghai street market in Google Cloud Storage, I can just access it with this URI. Okay, and all I do is I create an image annotator. I create a construct for the image. I pass in the URI for the image to set up the image. Then I'm going to say, hey, detect some labels, and then now print the labels and the confidence score, and then display the description as well as the confidence score, just like we did on the previous page. And by the way, this is using fstrings, which is a new feature that was added to Python 3.6. So you have to have 3.6 to run this code. With the previous example, I used the lowest level. You can run it in Python 2. All right? So let's go to this image. So here's the street market in Shanghai, and here are the labels and the confidence score, just like what we saw with the previous image of the fellow, right? It's just that this is a different image, but the results are similar, right? By the way, there's a shorter link to this. If you want to access this app where you actually build build sort of sample scripts that do 4 features of the Vision API, this is one of them. I'll do one more, but I'm not going to do the other 2. There's 4 sample apps that you're going to build using that code lab. So a code lab is a self-paced hands-on tutorial. This is the long link to it. I'll read you the short link to it. It's g.co/codelabs/vision-python. Yeah, that's it. And otherwise, this is the full link. So by this time, we're already on step 6, right? So the first several steps are setting up, getting credentials, turning on the API, and all that kind of stuff. But once we get to this first example app, this is already page 6 of the tutorial. It's only it's less than 20 minutes to do these 4 apps. You're just cutting and pasting, right? All right, so let's look at another feature in the Vision API that we have not seen yet, which is OCR and detecting text. Okay, so similar, this is a different image. Okay, same setup. This time I'm doing text detection instead of label detection. Okay, and now print the text and then show me the bounding vertices where it finds the text and then display it to the user. So here is the image, And I'm going to ask it to read text and OCR out of this thing. So it finds caution auto crossing for the next 6 miles. Looks pretty accurate to me. And it shows you like in which bounding box in this image, like pixel XY to XY, where is this text found? Okay, so this is the second app. And then there's a third one, which is detecting a landmark. It's a picture of the Eiffel Tower. Okay, and then the fourth one is the facial features, which you've already seen before. Okay, so those are 4 apps that you build with this code lab. You do it line by line. We explain everything about how this thing works, and then you'll be very familiar with the Vision API. Oh, maybe I do show it. Let's see if I show it or not. Okay, this is the landmark one. I'm not supposed to show this to you. We need to move on. Okay, easy, easy. Even detects the gardens, the Trocadero Gardens, where the Eiffel Tower sits on top of. I wasn't supposed to show this to you. I don't know why. Okay, maybe I left this one in, but I left out the other ones. Okay, good. If you want a fun demo of the Cloud Vision API, go to quickdraw.withgoogle.com. Okay, so it's like a Pictionary thing. Okay, so what happens is it gives you 3 objects, one at a time. You have 20 seconds to draw that object in a way that the Cloud Vision API can actually recognize your horrible scribbling. Okay, so that's pretty fun. You can have your kids do it too, but it's a good demo of how Cloud Vision API works. All right, let's move on to the next one. So this is the Cloud Natural Language API. It helps you reveal the structure and meaning of text. It performs lots of different operations, including content classification and sentiment analysis. It also does things like entity extraction, which means it knows how to recognize proper nouns like Google or Android or Mountain View or San Jose or PayPal or whatever. And it also does entity sentiment analysis, I think. And it also does syntactical structure, so it knows like noun, verb, object, and things like that. Pardon? Oh, yes, right. Yeah, that's exactly what that other feature is. So anyway, so it does like 5 or 6 different things. So let's do 2 of them. Again, there's going to be a demo at the home page where you just type in some text, all right, and it analyzes it for you. Okay, so the default text that you get is this one that shows up in the web browser when you go to the home page. All right, so we're going to do sentiment analysis on this one. So in your heads, figure out if this is positive or negative. Okay. The other thing we're going to do, the other feature we're going to use is content classification. So this text, how do you classify it, and where would this text be found generally? All right, so what do you guys think? Positive or negative? Why? Okay, good. And you guys are correcto. If it's positive, then this will be a number between 0 and 1. If it was negative sentiment, it would be between 0 and negative 1. Now, how many words told you that this was positive? How many words indicates positive? Just 1, which is love, right? So that's why the score is a little low, because it only found 1 signal. However, is love a strong or a weak word? Pretty strong, so that's why the magnitude is higher. Okay, if you change this to like, then this score would probably stay 0.3 because it's still 1 word, but then the magnitude would drop. If there were other words that indicated it was positive, then the score will go higher. Does that make sense? So now you guys have an idea how it works. Now, categorization. 76% chance is internet telecom related, 64% chance it is computers electronics related, and 56% chance it's news. Okay, cool? Everybody get how this works? All right, let's move on to the next one. The speech APIs. So this is speech to text, text to speech. You know, I don't have a demo of this one because we're short on time, but this will basically take spoken speech, like an audio file, and it will transcribe it into text strings that you can process with a program. And then vice versa, you can have text strings, and then you could actually give it a voice. Male, female, where are they from, what accent do you want to have? So there's a lot of different choices that you have for this. And it's they're multilingual as well, too. Okay? So speech and then text to speech. We also have video intelligence. So this is kind of like the Vision API, but instead of a single still image, it looks at every single frame of an entire video. And so it will do many of the things that the Vision API does, but then it will do some extra things which are unique to videos. Like, for example, if you uploaded your video of what you did over the holidays, it can identify when you had dinner with relatives, when you went skiing, when you spend time with your family, when you watch TV or whatever. So it can identify chunks, so you can index a video, basically. It also can tell when the angle changes, like if you have multiple shots with different cameras and things like that, so it can recognize that as well. So lots of different things. It can also extract, it uses the speech-to-text API to be able to transcribe the audio that's in the video as well too. So lots of different features here. Again, you can go to the home page, upload your own little video, or you can use some of the pre-existing ones that we have as samples that are on the home page. Okay. Another one is Google Translate. So this is just the API for Google Translate. So there's really not, obviously there's a translate text, source language, destination language, or you can also do it with auto detect, like you don't tell it the source language, you make the API, the model guess what the language is, and then what you have to tell it what you want it to translate to. So it has that call, obviously, but it has other calls as well too. So just take a look at that API. And then we have something more magical called Automail. So as you saw in the earlier slide, we had a diagram of, well, we're going to stay on the left-hand side and just use the APIs, right? And let's say that you're still not quite ready to go build and deploy your own model using TensorFlow yet, but you don't you want to use the API, but something that's a little bit more customized. For example, I gave a guest lecture for a professor who was teaching at UCLA, who was teaching a graduate course. And while the Vision API is great at recognizing a bird, a dog, a cat, and a muffin, it's not so good because that class focused on medical imaging, right? Or maybe you have an application where you're analyzing construction blueprints. Well, that pre-trained model isn't trained for medical images nor construction blueprints, right? So maybe in this case you want sort of like a customized version of the Vision API that's customized for your data set. So AutoML is not an API, but it's a special sort of extra feature on top of all these existing APIs. So let me get out of the way. Translate, Vision, natural language, video intelligence. So the AutoML versions of these APIs are basically taking these existing pre-trained models and allowing you to upload and further customize those pre-trained models, but for your data. Okay, so speaking of muffins, you can pretend that the regular APIs are like cupcakes, and then AutoML is like the frosting. You can eat it without the frosting, but the frosting makes it more specific to what you like, right? So that's what these are. The last one is a little bit different. The last one, there really is no API for the non-AutoML version, but if you look at the icon carefully, it looks kind of like a spreadsheet. Okay, so it represents structured data. Okay, and AutoML tables is the newest of the AutoML APIs. And so let me describe really briefly what it does. In fact, if you do the hello, I'll just tell you what the hello world does, because if you try it, you're going to run into the hello world anyway. So the hello world has like a list of like 100,000 data that looks something like this spreadsheet. It's got what country you're from, it's got your profession, it's got your salary. And then there's like 100,000 people there. And so what happens is you train this model on AutoML tables so that for new data, if you upload what country they're from and what profession they have, it should be able to predict what salary that person would be getting. Okay, so that's AutoML tables. Like I said, there's no non-AutoML version of it. It's just a spreadsheet or a database, right? But now you can do predictions on structured data like that using AutoML tables. All right, so how does AutoML work? So if you wanted to use AutoML, what you would do is very much like what you would do with TensorFlow and Keras. You would prep your training set, you would create a data set, you would import items into that data set, then you're going to create and train your model and evaluate it to test it to make sure it works, and then you can make predictions on new data. All without much experience with machine learning. So you're actually doing this training without having to do it manually using something like a TensorFlow, right? The API allows you to do that. So we're finding that a lot of students are leveraging this in their student projects by using the AutoML versions of these well-known APIs. So it's a pretty cool way of doing training without knowing much about machine learning at all. Okay, so this is a really, really cool feature. All right. But let's say you're more sophisticated now. Maybe you're ready to go and do your own TensorFlow or scikit-learn or PyTorch, right? So, but then you have to get your own infrastructure. You have to get your own VMs, you have to get GPUs and all this kind of stuff. But if you don't want to do that, Cloud ML Engine allows you, it basically is your infrastructure that's fully managed by Google. So you use it like a regular API, but it lets you build, train, and deploy your machine learning models, whether you use a well-known, all these, you just pick any one of the well-known libraries, and you can build and train and deploy your models, and then make predictions using those trained models, all within sort of like the confines of the ML engine, okay? So that's that. And then, if you really want to do it yourself, and you're going to get GCP or GCE, Google Cloud Engine, Google Compute Engine VMs, and you want to attach TPUs to it, there's an API that lets you do that. So you create Compute Engine VMs using that API, then you use a TPU's API that gives you access to a TPU. So a TPU is a piece of hardware that's specifically made to help you reduce the training time, okay? So the way it works is if you go to the home page, you'll see that it works like the following. One TPU is 27 times faster and 38% cheaper than 8 GPUs to train with. Okay, so it provides a significant improvement in the speed and the cost of doing machine learning training of your own models. Okay, so it's pretty cool, so check it out. All right, so those are all the GCP APIs that you should consider. Some other APIs as we get a little closer to the end here that you may want to consider are the following. BigQuery. So BigQuery is our it's a data warehouse, but it has a little bit of machine learning, a little bit of storage. So I color-coded these things. Storage is blue color, machine learning is green color, and then big data is purple color. So this is kind of an interesting hybrid tool. So if you've never heard of BigQuery before, it basically lets you query multiple terabytes of data in seconds just using simple SQL. So if you have a lot of data, it cannot fit inside MySQL, and then you end up having to break it up, like 8-way sharded MySQL, and then you have to map reduce things together in order to produce a query. Now that's too much work. If you just upload all of your data to Google Cloud Storage or stream it directly to BigQuery, you can get results in seconds using SQL, not hours, days, weeks, or whatever. Right? It's very, very fast, and it doesn't really matter how much data you give it. The more data you give it, the happier it is, basically. Okay? And there's also a little bit of machine learning. So the machine learning that it has is it can build a model based on the data that you have in BigQuery. And it's actually very similar, complementary to AutoML tables. Whereas what you had in AutoML tables is fixed, kind of rigid, relational database or spreadsheet data. BigQuery is obviously a much bigger data set. So you can actually do something like an AutoML tables using BQML, and that's built into the BigQuery product. Okay. So as an example, I apologize, this is not multi-terabytes, but imagine all of Shakespeare's works put together. For some reason, Shakespeare only wrote in plain text. Right? He didn't have a lot of multimedia or images for some reason, okay? So this data set is really only like 36.5 megs, so it's not a lot. However, this is a task that you don't want to do as a human anyway, right? So if somebody to ask you to put together every single word that Shakespeare wrote and then sort it in order of what were the most commonly used words, you still don't want to do that by hand, right? All right, so, but you can ask this using SQL, like make this a case-insensitive sort, add up all the word counts from one of the free public data sets that you get in BigQuery, group it by word, order by the kind, in descending order, give me the top 10, okay? By the way, BigQuery has a ton of free public data sets, and BigQuery is, it's actually one of the few products that you can use for completely free without even a credit card, all right? So we let you make up to 1 terabyte of queries for free every month, all right? And using any of the public data sets, and it won't cost you a penny or a dime or anything. All right, so actually a lot of people love BigQuery because they can do crazy analysis. So besides Shakespeare, we also have like weather station data back to the 1920s. We have like the Health and Human Services neonatality database so that you can write a query like, what was the effect of smoking to mothers who gave birth to children between 1957 and 1962? Right, you can ask a very, very targeted question using SQL with these free public data sets and actually get an answer. And you'll discover that the babies that were born to mothers who smoked generally weighed about 1 pound less at birth than children who were born to mothers who did not smoke, right? But you wouldn't have known that by guessing. You'd have to read through a lot of data, all right? Why not have BigQuery do it, okay? So those are just 3 of the BigQuery public data sets you get. Like I mentioned before, you can make up to 1 terabyte of queries a month completely free without being charged or without even plugging in your credit card, which is great. Okay. So anyway, so what words would fall into the top 10 of what Shakespeare wrote? The. All right. Then when? Thou. Okay. Not quite for thou, unfortunately, but the is the #1 answer. All right. Thou is probably in the top 20, but not in the top 10 for some reason. Okay. Imagine doing about 30,000 hash marks on a piece of paper as they're counting it by hand, right? You don't want to do that. The other cool thing is that BigQuery has a web interface so that you can actually just access the free public data sets directly and just click, run query, edit, run, so you can perfect your query. When you get the results that you want, you can download a CSV or do other things to it. But again, you can use this for free every month, 1 terabyte of queries. All right, that's BigQuery. Compute Engine, if you want a VM, right? So if you're going to get ready to do your own and you want to access TPUs, you have to use a Compute Engine VM. So you can get anywhere from a micro, really small, I think 2 gigahertz CPU, 4 gigs of RAM or something like that, pretty basic. You get that for free every month. That's part of the free tier. You get 1 free VM a month, F1 micro. All the way up to, if you want 416 vCPUs, nearly 12 terabytes of RAM, or 64 terabytes of disk. But I'll tell you this, that machine is not cheap. Okay, it is about 80 bucks an hour. Okay, but if you need to have it, you need to have it, right? So anyway, GCE supports multiple distributions of Linux as well as Windows Server, so you pick and choose which one you want, and then you basically allocate a machine anywhere from between this and this. These are the 2 extremes, obviously. You can get everything in between. If you don't want to manage your own VMs and you just want to call APIs and you have an app, you created a web app, you want to host it, just do it on App Engine. You upload the code, we run it for you, so you don't have to think about infrastructure. Okay. If you don't want to write an entire app and you just have like small little microservices that use machine learning, you can do Cloud Functions. If you have a mobile app, you can use the Cloud Functions for Firebase, because Firebase is Google's mobile development platform. So many of you may have heard of the Firebase real-time database, but when Google acquired the company, they added all these mobile app features like app indexing, deep linking, crash test reporting, virtual Android device testing, so you can actually test on devices you don't own, like in different parts of the world, so that you can ensure your app works for everybody once you launch. So it has a lot in analytics. So it has a lot of different mobile development tools that come with Firebase. So if you're going to do mobile stuff, you might want to try this one, but if you're going to stick with more of the cloud stuff, then use the regular generic GCF. All right, spreadsheets, like I said earlier, they have an API too. Maybe you want to take your big data, instead of throwing into a CSV or a database, maybe you want to put it into a spreadsheet. Maybe you want to tell the Sheets API to make a chart, right? Pretty easy to do. And then, it's data's in a database, but it's not really visual. Whereas what's in a spreadsheet, it's in a user interface that everybody understands, right? And then chart's even better. It's like a bonus, okay? So my manager wrote a cool code lab to get you started with the Sheets API if you're a Node developer and you want to learn how to use the Sheets API in less than half an hour to build a customized reporting tool for a fictitious toy company, all right? In fact, I reuse that in this sample. I just basically, my job here is taking the data out of that relational database in his code lab and creating a blank spreadsheet and then uploading all that data into a spreadsheet starting at cell A1. So that's just a simple example of how to migrate SQL data into a spreadsheet. Then we have the Slides API, because the Slides API is more visual, right? If you're going to show off to your boss that you did something useful, then you can take data from a spreadsheet or from a database, use a Slides API, and generate a slide deck out of it. And then here's the code lab to get you started with the Sheets API. It uses BigQuery as well too. Basically analyzes all the projects on GitHub and what licenses they've picked and makes slides on each one, which is pretty cool. So here's an example of how you import the Sheets. You told Sheets to have the information, you made a chart on it, but maybe you want to bring them both into a slide deck. So this is what you do. You would say, make me a table, make me a chart, grab the chart ID that I put into the sheet, and then create the table that has the exact rows and columns, and then I don't have the code here that actually populates it, but you just basically read in all the rows from all the cells from the spreadsheet, and then you just populate this table that you've just created using the Slides API. Okay, pretty basic. And then we have AppScript. AppScript is for those of you who are sort of like newer programmers or programmers that are not full stack developers, but you still want to code, but you don't want to do all this REST API stuff. You don't want to do OAuth. You don't want to do HTTP. If it's too complex for you, you might want to consider AppScript because it is a customized version of JavaScript which gives you access to more than 40 Google services, including some GCP ones, and you don't have to do OAuth or APIs. All right? And so here's your hello world, your one line. You can get a spreadsheet and put hello world into it, but notice there's no OAuth code here. I didn't have to create an endpoint to the API. I didn't have to get OAuth credentials. OAuth credentials are automatically generated by the AppScript system. And so when you run it, you'll have hello world in your spreadsheet, which is pretty cool. And then if you want to start doing real stuff with data, like this address here, you can actually call the spreadsheet to pull out the value of that cell A2. You can say, hey, Google Maps, even though it's not part of G Suite or Google Apps, you can tell Google Maps to make a new map, put a pin on that address. Then you can tell Gmail, hey, Gmail, send this map to my friends so they can come join me for lunch or whatever, right? And then you can take this app and build something more useful, like maybe 4 of your salespeople need to visit your top customers in New York. Now you can do that. Because Google Maps has driving directions, walking directions, and public transit directions, you can give them that too, right? So if you're managing a user group or a book club, you can kind of take that 4-line app and kind of run with it, okay? So here's an example of how you would use AppScript to access the natural language API. So this is a code lab you can try, g.co/codelabs. This is NLP docs. And so what this is this is an AppScript app that lets you highlight things in Google Docs, pull up natural language, click on mark sentiment, and then it will highlight it in green if it's positive and then red if it's negative, okay? So that code is pretty basic. Looks something like this. Here's this one's using API key, right? No OAuth, because I'm only passing straight up text to the natural language API. So you just create the JSON payload, and you say, hey, here's my API payload, call the API, get the results, and then I forgot where it actually marks it up, but maybe that's a different piece of the code. So anyway, so I just want to show you can access GCP ML APIs from AppScript as well. AppScript powers add-ons. So if you do add-ons, that's great. And then to kind of wrap up, I just want to run through a couple. I'm going to go over by 2 minutes or so. So here's some inspirational apps that use both GCP and G Suite. Okay, so just for fun. My colleague wrote an app that adds custom intelligence to Gmail by analyzing G Suite data using GCP. So what did he do? He said, oh my gosh, I get a lot of email. Gmail does a great job of filtering spam, but maybe I only care, even with a non-spam, maybe I only care about certain messages. And for him, he only cares about messages where there's an attachment of a bird in it. All right, I know that sounds weird, but this is how he was motivated, okay, to write this app. So what did he do? He wrote an app so that every time he got a new Gmail message, it sent a notification to Cloud Pub Sub, which then extracted the which called a Google Cloud function to extract the attachments in his email. Then it sends those images to the Cloud Vision API, and where it gets all the labels. And if one of the labels is bird, then he calls the Gmail API and stars that message. So without running any code explicitly, the next time he checks into his Gmail, some of his emails have stars in them. Okay, kind of crazy, but it's an interesting use case of both G Suite as well as GCP. Another example, so if you want to find out how it works, here's some links. And then another example I wrote is going from big data analysis to slide deck. So you already kind of have a preview of this, where we use BigQuery. It's great. It's awesome. And we use the power of BigQuery to get these results. But what are you going to do with it? You're going to put it in a CSV file or put it into a database? No. I already told you, okay? And doing this, you've done the hard work. This is 80% of the hard work. It's like these stairs. It's 80% done. I could use it, but it's not really pretty. And remember how I said a spreadsheet is nicer to look at? So stick it in here instead of a CSV file, right? And then tell the Sheets API to make a chart on it. And then the next step, again, I told you already, is, well, read that chart into a table in a slide. Import the chart into a slide so that you have a slide deck, right? So this application is an AppScript app where I'm sitting at the console, I click the Run button, it calls BigQuery, sends the results into a sheet. I tell the Sheets API to make a chart, then I create a slide deck. Then I import the data and the chart into the slide deck, and then boom, you're done. So I went from big data analysis all the way to exec-ready slide deck in less than 100 lines of JavaScript. Less than 100 lines. It's really compelling, right? So I have a code lab to let you build this step by step. You can also watch the video or say, screw that, I just want the code. So here's GitHub. And then I gave some talks at Cloud Next on it. And then to wrap up, summary and some resources. So machine learning is solving harder problems by making computers smarter and analyzing lots of data. Okay, so how do you do machine learning again? You have lots of data, you label it, you build and train your model, then you validate it. Then you use your model to make predictions on new data. Do you need lots of experience with ML to get started? No, just use our pre-trained models using APIs. And then AppScript gives you an easy way to do it with just API keys. Or you can also do it in Python and JavaScript with API keys as well too. Okay? All right, so more information on AppScript and G Suite. More information in the docs pages on all of the G Suite APIs, the machine learning APIs. And then your next step is to further train our models by customizing them using AutoML. And that is it. So here are the slides. Take a picture. You're going to ask where the progress bars. You're going to ask where the progress bars are. I apologize. There's no progress bars to be seen here, but neither, PowerPoint and Google Slides does not have progress bars. So a teammate of mine actually wrote progress bars. You should have seen a progressing progress bar, but I didn't get a chance to run it for you guys today. So anyway, so grab the slides at the short link or at the image here. My daughter says Happy Halloween. And then here's the open Google Doc with questions again, because I don't think we have time for questions. But I'm going to hang around outside for a few minutes in case you guys have questions. All right, thank you, everybody. Please tell me you learned something.